See this problem. 4-point charges QA is equal to 2 microcoulomb, QB is equal to minus 5 microcoulomb, QC is equal to 2 microcoulomb, and QD is equal to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeters. What is the force on a charge 1 microcoulomb placed at the center of the square? Our motive is, so there is a square area. So at the corners of the square, 4 charges are placed: QA, QB, QC and QD. So they have their respective charges. So at the center, like it is the cross point of the diagonals. So at the center, a small charge has been kept, and we need to find out the net force acting on that small charge due to these charges. That is our motive. Now come to the investigation part. QA is equal to 2 microcoulomb and QB is equal to minus 5 microcoulomb, QC is equal to 2 microcoulomb and QD is equal to minus 5 microcoulomb. And small q, charge kept at the center, is Q is equal to 1 microcoulomb and the side of the square is 10 centimeters. To find the net force, I want to resolve. So assume that I have an object which has been pulled by two forces, similar forces in opposite directions. Then what should be the net force acting on the body? 0. The net force acting on the body is equal to 0 because two equal forces acting in opposite directions on the same object. So if we consider the same for the given thing, so here QA and QC are same. Those are applying force on charge Q. So here QA and Q are positive charges, so there will be a repulsion between these two charges. So even between QC and Q also there will be a repulsion. So these repulsive forces are same and acting in different directions, like opposite directions. So the net force acting on Q due to QC and QA is 0. And when come to the QB and QD, here QB and QD are also same, but those are negative charges, so they will attract the charge Q with the same force. So QD and QB are individually attracting charge Q in opposite direction with the same magnitude of the force. Then the net force acting on Q due to QD and QB is 0. So on a whole, due to these 4 charges, the net force acting on Q is equal to 0.